Thanks for coming along to my talk. So hopefully you're in the right talk. It's a talk about Scala and how it's been used in some GovUK digital services. Can I have a quick show of hands just to see who's using Scala on a daily basis here? Okay, that's cool. That's fine because I've kind of catered my talk assuming that people may not know too much about Scala. So I was like hoping that I wouldn't be disappointing more if you were all kind of like seasoned Scala devs and you'd be like, show us some new fancy techniques rather than the actual syntax of the language. So quite a few of you are new to it, so it's going to be pretty cool because we're going to work through some basic examples too. And then we'll actually look at some Scala code on some real projects too, so you will see it being used from some real code. So a little bit about me. My background is Java and Scala. Some of the projects I've worked on are there. Some of the other stuff I do is committing to open source, involved in the local meetup that Viv arranges, the Swansea software one. I am Swansea based. I'm proud of it, and I'm really cool. It's really cool that we've got this conference. I'm genuinely pleased about that, to see stuff happening in the development community in Swansea. The other stuff I get involved with is I'm also married with 3 kids. So I have a busy life. I know there's always people who are kind of like, get in there and show me the code. My introduction won't be that brief. Probably 5 minutes or less will be there. So we're going to look at the what and the why of Scala. We're going to obviously look at its usage. We're going to look at examples specifically from the DVLA. It's no big secret that DVLA are based in Swansea, and of course they're kind of probably the biggest place that you can go and do software if you're looking from an enterprise perspective in this particular city. And then hopefully we'll have some time for some Q&A. And I'll also have to excuse myself saying I haven't really timed myself on this talk, so I don't really know whether I'm going to end early or run over or whatever, but we'll see how it goes. So Scala. How many here have used Java at all? Okay, that's probably roughly half of you. Scala does run on the same runtime. Now, the Java runtime is well known, well understood, well supported by lots of tool suites and servers. It's kind of got a reputation to be trusted by ops guys, which is always good. So if you're looking to bring in Scala into an enterprise, or it might be just a small startup, you'll know that it's going to be running on something which is really well tested, really well supported, and really well understood. That's a good place to start. So by bringing in the new language, you're not bringing in a whole new runtime. That's really, it's a big selling point. And Java interop up there is the big one. So you can use Java code as is with very little friction at all. And similarly, you can use code that's been written in Scala from Java. Now, there are some little subtle differences and things that you've got to work through, but it does make it as simple as possible to deal with. Then type inference. That's a really big thing. So Scala gives you the feel of a dynamic language, say something like, I don't know, maybe Ruby or even JavaScript maybe. It's really easy to knock out things. There isn't a lot of boilerplate stuff. There isn't like lots of marking of where the types are, etc. The compiler does an excellent job of working out what should go where. So it doesn't need you to hold its hand, a bit like Java does, right? I mean, Java 8, okay, and 7, it got better. But you typically have to go, I want a list variable of this type, and I'm creating a list variable of this type. It just became a little bit verbose, really. Then concurrency. Concurrency has been thought about from the beginning of the language. It isn't a bolt-on. There is first-class citizens such as futures. I don't know if you've ever worked with things like that, but essentially computational units that can be just spawned off on other threads in a very transparent manner to you as a developer. You don't have to manage all the stuff around the threads and the concurrency. But it gives a really nice high-level abstraction API to work with. Traits. Traits are really cool because if you're familiar with interfaces from Java, they're essentially just like the definition of behavior. Well, with traits, they can also have state in Scala. So you actually have this nice mix. And actually, in order to achieve some of the cool stuff in Java 8, they've actually done the same thing there. The interfaces are a bit more clever now. They can have default methods and default implementations. Pattern matching, we're going to look at that. That's really powerful. So the way that you interrogate your code when you want to do conditional statements is a whole lot more powerful than what you might have experienced in other languages. It's got higher order functions. You can basically think of a function maybe returning a function receiving a function. Functions are first-class citizens, and we'll see more on that later. Okay, show me the code. We're probably only 2 minutes away. So I would summarize Scala, which is kind of an acronym for scalable language. And it means scalable in the sense of it can be used for very small projects to very advanced projects, and at varying degrees of complexity as well. Martin Adersky, the inventor of the Scala language, has a really good paper actually about different kind of Scala devs, and he kind of explains what maybe like a beginner and what an intermediate and what an advanced and like a library code developer might do. The cool thing is about Scala is that the barrier to entry is really low. One thing that I would suggest to you is if you do get to try out this language is not to be afraid to kind of take baby steps, as it were. There's kind of a bit of pressure in the Scala community because of the complex stuff it can do, to kind of go in at the deep end and kind of completely change the way that you approach writing applications. It's definitely worth considering those new approaches, but some people are afraid of writing Java-esque code in Scala, and there's absolutely no reason to be afraid. That's absolutely fine as a way to start. Another cool way to introduce Scala into your organization, because I don't know, you may be sat there thinking, well, it'd be nice to introduce a new language, but it's unlikely that I would ever get that past manager X or architect B. Well, how about using Scala in a test to begin with? If we do get the chance, I'll try and show you what maybe some tests might look like. If you were in Trisha's talk, she showed you some groovy and a bit of a nicer way of representing your tests. There's plenty of that in Scala too, so you might be interested. So, in summary, scalable language is that object-oriented meets functional. So you think of the good stuff about object-oriented languages, and functional languages such as Haskell, Lisp, that you may have come across, maybe at university level. Some of the functional stuff is really sound and perfect for concurrent programming. And if you can fuse these two together, which Scala tries to do, it can be really powerful. Let's have a look a little bit like maybe how traits may look. I'm not sure how well this reads right at the back of the room. I apologize if it doesn't read very well, but so imagine that you had a spacecraft that has an engage method on it. You might then further kind of elaborate on that and say, well, a commando bridge is a type of spacecraft which has a speed-up method on it. So in order to kind of engage and launch that spacecraft, you've got this speed-up method now. And then you might further extend that and say, well, okay, I have a pulse engine, and that's going to basically work on the basis of pulses to increase speed. And then you might end up with, well, you know what, actually I want a star cruiser, which is a type of spacecraft, but it's also got a commando bridge interface way of using it with this pulse engine feature. And you see what this concrete class has eventually become. It's got a bunch of mixins in it. Now this is really powerful because this is essentially like multiple inheritance, but without the pain of it. So you may have come across multiple inheritance maybe in a language like C++, and it's not a feature that was brought into Java for very good reasons. But the way that this does it does it through something called class linearization, which isn't a very nice word to say, especially on a stage, but what that means, ultimately, is that it's going to bring all of these traits together and actually create you a concrete class, and it's going to work out the best that it can do, and of course the compiler will tell you if it can't do it, how it brought together spacecraft, commander bridge, and pulse engine into a single unit. So you can see this is a really cool way of building on pieces of functionality, and actually this thing has got like a name called the cake pattern. So it's kind of like the idea that you bake bits of functionality, and in some circumstances you might want to bring that together. Okay, pattern matching. What's all that about? Okay, so imagine that you have an abstract class. The keyword for kind of saying that you can't further define that abstract class is that you have sealed. Okay, so it's a bit like the final keyword in Java. So you have a sealed abstract class of tree, and then extensions of that are node and leaf. Okay, and you notice here this is a case class and a case object, and that basically means this is a special type of class in Scala which can be used in case statements. Okay, so if we look at this method, the idea is that this will all return an in-order traversal of this tree structure. So what it's going to do is it's going to receive your tree structure, and it's going to return you a list of basically each node within there. Now, the way it can achieve this is that it can do what is called a pattern match, just using this match keyword, and then you have these case statements. And you can see this is really powerful, because this is saying, if this tree is of type node, then I want you to extract the element, the left, and the right. So you can now assign these variables all in this one statement. And you can see beyond this lambda part of the expression, you can now say, well, it's going to do a recursive call to itself, concatenate that to a list of E, and again, concatenate to another recursive call to in order. If you've reached the leaf, of course it's an empty list, because there are no further nodes to expand. That's very powerful, right? Because you've got this extraction of the class hierarchy. So what's really nice here is it's used functional principles to expand upon some object structures. Now, in Java, you'd be doing if you wanted to achieve something like this, you'd be doing some horrible instance of statements and whatnot. So this is much nicer. So you can see the power of trying to fuse object and functional together. Okay, and another example, and this is a much simpler example here. So what we've got is an array of people, and let's say we were to populate that with a bunch of people with varying ages. We could very easily partition that list. So this is kind of like an example of a high-order function. So on an array in Scala, you have access to a function called partition, which itself takes a function. So it basically says, I can partition a list for you, just give me the criteria that you want, and give me the criteria for partitioning as a function. Okay? So you can now say, well, this special underscore character essentially saves you some boilerplate code, because you could define, well, the input parameter name of person, and then you could give the lambda syntax of equals, and then less than, but you don't need to. You can just say underscore dot age, so there's an age property on the person, and then I'm going to check if they're under 18, and that's going to mean that you're going to end up with two variables here. You're going to get a minors and an adults. Really simple, right? I mean, the equivalent Java is here. Anyone who's done Java will know, yes, okay, create yourself a minors list, create yourself an adults list, and then go and do your imperative looping. Okay? So that's really powerful, right? And you know, to me, one of the biggest wins of using Scala was dealing with collections, because it's something that you have to do so frequently, right, in programming. And the fact that you can deal with them in that manner just makes life so much simpler. Okay, so the REPL. Put your hands up if you've heard of a REPL. Okay, there's a few of you. I'm pretty sure those were roughly the same hands that the people who use Scala. It isn't a Scala thing only. The principle does date back to other languages. But it's a read-eval print loop. Okay? So basically, it reads your input, it evaluates it, it prints it back to you, then it loops. The key thing of looping is that it means that it's going to understand the previous state and you're going to be able to continue interacting with it. So we're going to jump into the Scala REPL. This is always the dangerous part, right? When you actually try and do some live coding. I do kind of have some backup copy-paste jobs, if necessary. Okay, so I'm just going to make sure that we get the right size for everyone here. You let me know if you can see what I'm doing. So, to enter that, I can just type Scala, once I've installed Scala, of course. I didn't think you'd appreciate a demo of that. There is a feature of this REPL that I can activate by doing this. But I tell you what, I won't complicate matters, I'll go into it for now. So if I just type Scala, I enter its REPL. And what it means is I can just type in expressions and get playing with the language. This is really powerful, right? Because you have an idea, and you think, well, I want to see really quickly, I want to prototype, if you will, to see whether this thing would actually work in principle. So, you know, you're at the beginning of Scala, right? So you go, okay, well, how do I use this thing? How do I define a variable? Well, it looks like this. So, val foo, and who else uses these crazy names? Val foo, and blah. And I've actually just defined a thing called foo, which is a type of string, and it gives me the value of it. This is really cool, because I can actually start doing stuff with foo. So I can say, if foo equals law, then I can echo out, I can do is say a print line. I know, probably the silliest code you'll ever write, right? But it gives you an idea of how powerful this REPL can be. So now, right, okay, so this is really cool. I'm interacting with this new language that I'm trying out, and I can do this stuff. Let's go back a step. If I quit out of here and just, so, it'd be nice if I typed that correctly. Okay, if I quit out of here, I'm going to go back in, but this time I'm going to activate a feature which just gives me a little bit of syntax coloring. So, Scala color. Okay, that's a bit nicer. Okay, so what we'd like to do is have a look at a little problem, maybe something that will tell us what the outlook is for a given year. Okay, so I don't know, maybe the method for that would be, we can define that to be, oh, by the way, that val keyword, I was defining a constant there. And you notice I didn't have to like define types on that variable, it just worked it out. That was pretty neat, right? Yet Scala is a compiled language and it's type safe. But, I mean, can I just have a quick show of hands from the code that I typed just then? Like, who would have thought that that was a compiled language? Right? It gave a feeling of being a dynamic language, right? It was really neat. So to define a method, I'm just going to say def outlook. Okay, cool. And within there, I'm going to take a year. So I'm going to have a year parameter, which takes an int. And what shall I return? I'll return a string of a description of what the outlook is for a given year. And we'll just set this to something silly, because we're just starting out. And we'll say the outlook is bright. Okay, cool. I'm going to do something really risky here and try and turn this a bit, so I can see what I'm typing here. Cool. Okay, so we have an outlook method as defined. It takes in a year int and it returns a string. Okay, so it gives us a method signature for it. That's cool. So if I just try this out, I can say outlook. I don't know, 2015. Of course, it doesn't really care about what the parameters that I'm passing into it, because at the moment it's just coding to always return bright. Okay, so maybe we can say that the outlook definition could be defined on basically whether there's going to be a SwanseaCon in that given year, right? Okay, because for me, I mean, it will be really bright if I know there's going to be a SwanseaCon 2016. Okay, so I guess that'll be based upon the success of this year. So, how could we look at doing that? Well, let's define a class. Yes, I can define a class on this REPL. It's pretty advanced. I'm going to go into something called paste mode, which essentially allows me to do multi-line and then kind of tell it when I'm done. So that's kind of nicer for typing for you right now. So if I say I have a class of SwanseaCon, I think we should probably have a value in there for year to tell us what year that conference was in. We'll also then have a Boolean variable that tells us whether that or not it was a success in that year. That will probably do it. So, okay, I'm still in paste mode, so if I do a Control D, you can get out of that. So I've defined class SwanseaCon. That's cool. Let's reset that screen so you can see. Is everyone seeing that code from the back? Is it big enough? A bit bigger, maybe? Yeah, I'll go just a slight bit bigger. Cool. Okay, so let's say I now say an instance of that class will be SwanseaCon 2015, and how would I access that? I would say new SwanseaCon, and the cool thing is, if you saw how brief that, really brief, right, compared to maybe what you've seen in other languages, but I now have a publicly accessible variable for year and for success. And because they're values, they can't be altered, so it's kind of like following the idea of, you know, a finalized state in the class. So once it's been constructed, you're not going to be able to modify that state. So the mutability principle, essentially. And then if I say 2015, because that's the year, and I'll say true, we'll say that it's going to be true. Okay, the conference is a success. So we now have SwanseaCon 2015 to play with. So I can interrogate its properties, so I can say SwanseaCon 2015, and say year, just to confirm that it should have the right year on it, and obviously success, if I spell it right, there we are, we have that true. Cool. That's good. Now, let's have a method in there, so I'm going to cheat a little bit here and paste in, so you can not have to worry about me doing all the typing. But we'll put it into paste mode so we can talk it through. Cool, so let's paste. And here we go. And we'll discuss that before I finalize it. Okay, so we have a find method that takes in the conference year, and it's going to return an option. Now I wanted to introduce you to this principle, because this is another really powerful thing. Okay, Java 8 now has it, but it learned it from Scala anyway. So you saw it was in Scala first. So I can wrap a type like SwanseaCon with an option. And that option has something called like monadic transform functions on it. Have people heard of something like that, maybe from the computer science theory, maybe? So essentially it comes from maths, and essentially you can have a function on something which will mutate it from one type to another. So with the option, the cool thing is I can like do things to that option. So I could transform SwanseaCon into a string and that kind of thing. But it's also, I mean, on the surface of it, it's a really cool way to represent a value that just may not be there. I mean, how many times have you come across programs that essentially just use null for that stuff? Which is quite ugly, if we're honest. This is a much more elegant way of saying, well, you know, this value, I might not be able to get it for you. You're asking me to find a conference in a given year. It might not be there, right? So this is a really nice thing to say, right? I mean, this is really expressive. So, and it forces the user to think about, oh, I need to handle potentially missing value. Whereas, kind of like the idea of if I just promised to return a SwanseaCon, but I could return you a null one, you know, if you were switched on about it, you might remember to do null checks, and hopefully if you're doing test-driven development, you would have added that as one of your success criteria, that it mustn't be null. But often that stuff gets overlooked in practice. So the definition of this method so far, and it's a little bit noddy, right? Okay, you have to forgive it because it's just a little demo in a conference talk. But we have a check that if the year, and actually I made a mistake here because this, because I changed my variable. So this should say if conference year equals 2015, then we're going to return the 2015 conference that we already have, right? Cool. Otherwise, if it's requested for 2016 and 2015 was a success, right? So that was our definition of success and why we should run one in 2016. Then we're going to return some new SwanCon of 2016, and we're going to say false for now because, well, it's in the future. We can't predict whether it's going to be successful yet. Otherwise, you get a none. So this is really cool. You can see that the concrete types of option are some and none. And the cool thing is, at the option level, is you have the necessary methods that you need to interact with it without having to care whether you got a sum or a none necessarily. Okay, so I'm going to quickly sort out my dodgy bit of code that I put there. And we're going to go for another try of getting that defined in here. Okay, so what we'll do is we'll exit paste mode. Hey, and look, the compiler told me, right? If I hadn't have done it, that's the really cool thing about this REPL. It's not going to allow you to type junk. It is going to tell you that, hey, look, you don't actually have a value called year. So let's get away from that. I don't like seeing red like that. Okay. Let's see now if I can define my class. Well, a method, I should say. Excellent. That is now working. So I now have a signature there. So I have a find, and it takes a conference here, and it's going to return me an option as well. Excellent. So we should give that a little test drive, I say. So we'll say find for 2015. Excellent. It gives me some, and then some. And notice here, this is kind of like the default behavior of the toString. So it tells you like the memory reference of the object. Of course, you can customize that if you would like to. Just checking how I'm doing for time here. Cool. Right. Let's just give it another test, say with a different variable. So 2016 we said, oh, excellent, cool. So we got another SwanCon returned here, and we notice there's a different memory reference, so it is definitely a different thing. So that's really cool. What about, if we asked for the outlook in 2017, we got none, because it's just, we don't know about that yet. Okay, that's really cool. So we should now look at what would happen if we introduce a case class. It would make this definition of this method somewhat better. So I think we can improve upon this find here. So I have one I prepared earlier, and hopefully that one doesn't have dodgy variables in it. But first of all, I'm going to have to redefine the class SwanCon as a case class. Okay, so let's go back up here. So case class SwanCon, and we have year and success, fantastic. So the only thing that changed is that I now have this keyword case in front of it, right? So we'll see what benefit that brings us in a moment. So I'm going to have to redefine my reference for SwanCon 2015 because now the definition of SwanCon has changed. Okay, that looks good. And my new find method, let's see. Paste that in. Cool, and that worked. Okay, so let's talk about this implementation. So, same signature, of course, nothing changed there. But what we can do now is we can do this matching on the existing SwanCon 2015 we've got. So we can say, okay, matching on there, right? Not caring, so of course we want to make sure that these are SwanCons in terms of type. We don't care about the year in this example. We do care if it was a successful, and we ask if the conference year that's been requested is 2016, right? And now we're going to return some SwanCon 2016 and false. Okay, cool. Now, in this example, we're going to say, well, okay, we're going to extract the year out of the SwanCon, and if the year matches the conference year, then we're going to return 2015. There's definitely some logic problems in here. This is definitely flawed code. And then, in other cases, we're just going to return none. So you can see that's really nice way to break this problem down using the case class. So if we now do find, let's see what we get. So if we get 2015, what happens? We get some SwanCon 2015. If we ask for 2016, we get that one. If we ask for 2017, we get none. Okay? So looks like it's kind of doing a similar thing. So finally, we're going to have a look at interacting with this option and the methods on it. So if we now look back at our definition of the outlook, remember that very first function that we defined? So we'll go back here. So now we're going to redefine the outlook function to use our find, and then we're going to map the result of that. So map is essentially your way of transforming this value inside the option. We're going to say, not caring about assigning this parameter a specific name, because we're not even going to use it here, but we know that if this value is present, then it's bright, because we've got one. We found the conference, it's bright. Or else it's grim. Okay? So let's see, define that. So we'll now say, what's the outlook for 2016? It's bright. And what's the outlook for 2017? It's grim. So hopefully a little bit of fun in the REPL that you can see. It's really good to interact with, and it's really good to try out. What's a really nice feature as well is that if you have a project, and you can probably imagine this scenario happening, you have a load of dependencies in your project, different libraries you're bringing in, and often that's the time when I want to turn to the REPL, and I want to say, well, what happens if I use this library in this way? That's typically the way you want to start prototyping, right? Well, I can actually bring up a REPL with all the project dependencies loaded on the class path, and I can start importing those and using those. So, really nice feature. Cool, so that was the REPL. And this is then a really cool tool. If you are not that keen on using the REPL and the command line, I really recommend that you go and check this out. So there's the URL, just typesafe.com, get started. So typesafe.com are kind of like a commercial entity that are backing Scala and some kind of Scala libraries. But really give this a go. This is really awesome. Once you've got it set up on your machine, you can just type in Activator UI on your console. It'll fire up a web app locally. And then you can browse like loads of different template applications that are built with Scala, and even some that are built with Java but using some of the TypeSafe stack, such as Play and Akka, which are libraries you may have heard of. And you can actually code there in your IDE. So it means that the barrier to entry for getting started with this language is really low. So you don't have to go through loads of pain to get your IDE set up and whatnot. And those who've done Java for any length of time will know that can be painful. Well, I've already shown you the code, so we can ignore that little warning now. Okay, so the usage in Gov UK, and I'm just checking the time. So here's a little snippet of how Scala is being used across government. It's really cool to see that this language is gaining traction. So definitely in the DVLA, I know about that firsthand. It's been used in the Department for International Development. If you've ever used Register to Vote at all, that government service, that was written with Play and Scala, and that's been a really successful app. It's scaled really well. HMRC are using Scala and Play all over the place. They're using it for front ends and for microservices, like for API stuff. And GDS themselves are using some Scala and Play. GDS, by the way, are like a spin-out of the Cabinet Office, and they kind of oversee government IT projects. And to be fair, they brought about some really cool change in terms of like the ways of working in government projects, and also kind of like opening up to new technologies. So here's the GitHub handles for a lot of those things. Yes, the code is actually on GitHub. No, it isn't spilling your personal details. Don't worry, and that stuff does get kind of security vetted and checked before it gets published out. But there's, AlphaGov is the GDS one. Thank you. 10 minutes warning. And we've got DFID, DVLA, and HMRC. You can actually go and browse their code and check it out. That's really cool. There's been such a change of culture in government IT of late. It's really cool. So, in terms of DVLA examples, I'm going to have to prioritize. So I think what I'll do for now is I'll talk you through, so that I can leave some time for questions as well, is I'll talk you through an API and Scala with Drop Wizard. The cool thing about this is that we're actually using Scala here with a Java framework, if you will. Drop Wizard is actually primarily a Java framework. So this gives you an example of the fact that you've got in drop as well. So if I freeze off on that slide and make sure I get to the right one. Cool. So look at the response mapper here. Okay, so a quick brief background on what this application is for, and I'll make sure I get that code nice and big as well. Come on, you can do this for me. Thank you. Okay, excellent. And if we close this off as well. Cool. So a little bit of background on this. So I was working on the View Driving License project, and the purpose was for citizens to come in and check their license, but also there's a need for organizations to come in and check driving data, restricted as it is, but they are, organizations do need to come in and check. So for example, car hire companies might need to come in and call an API and just make sure maybe one of their kind of members and frequent renters, they can just do like spot checks now and again. They can call into the API and just make sure do they still have 0 penalty points and whatnot. And it's especially useful for organizations which have professional drivers, so you can think of bus companies, etc. They can just call in at any time, with the permission of their actual employees to actually do spot checks on them. So in this example, we have this response mapper object. So it's an API, and of course, there is a specific definition of the types, the contract that we need to return for this API, but we have our internal domain. We need to map between the two. Very common problem. You'll notice here that I'm using something called implicit. Yeah. So these methods, person to driver and address, which are essentially just converting between these disparate types of our domain and the type that we need to return on the API. That's exactly what these methods are doing. But the key powerful thing is that we have this implicit keyword. Should be used judiciously, but it is quite a neat feature of the language, because it does mean that you can cut out a whole lot of boilerplate. So if we do a little check here, and we say, find me the usages of this. So we can say, okay, I don't want the test references. Excellent. Okay, and I'll make this a whole lot bigger for you, hopefully. And say goodbye to that one down there. Excellent. So in our import list up here, transforming to expand in this expanded mode. I've lost a bit of space there. Okay, there we go. Excellent. So we have our response mapper, and we want to be looking for where this is used. Okay, so it's actually imported here. Fine. So what we're doing here is, in this section, this is where we actually build a happy result. So we say we're building a driver data response with a special ID for this response, and we're saying it has this driver, this license, and this address. Well, we're actually just saying from the domain, we're saying driver get person, driver get license, driver get person, and get address, right? We're not actually doing any type conversion. Now, if you actually look at these methods, and if you look at person, well, that's returning an add API DTO person. This is actually a driver type value. So how can that actually work? Well, the magic is in this. Because if you put within scope, and of course you have to be careful with the scope, if you put within scope that I'm importing this, and that has implicit methods, and it can convert between the types of that the compiler's got the problem with, then it's done for you. So it looks a little bit like magic. It's not. IDEs have got really good now as well at showing you where implicits are being used, so you don't get tripped up by them. And you can see IntelliJ's way of doing this is just very subtle underline to tell you that it's it's been implicitly resolved for you. So you can see that's a neat thing. I am on 5 minutes, and I do want to leave a bit of time for questions, so I'm going to pause there. If you are desperately wanting to look at more detailed code examples, I'm more than happy to sit down with you. I'm going to be here for today and hopefully tomorrow as well. So I'll leave it there for questions. Are there any at all? Okay. Okay. Yes. Yes. So the idea is, so I'm skipping through all of the stuff, there's all the stuff that you've missed out on, I'm really sorry. Bring up my Q&A slide. So the approach is that they're saying, well, there's times when you'd like to mix different parts of behavior together and compose functionality. And with the traditional kind of structures that you've got, just an abstract class, and then maybe the concrete class, and the interface. Of course, you can do, you can implement multiple interfaces, but that doesn't actually give you any actual implementation. Yes. Yes. Correct. So the way it's resolved in Scala is that it's based upon the specificity. So if you have if you basically bring in two traits that define the same method, it's going to use the latter one. So it will override the first. So of course you have to be careful with it, but it's usually used where you need to bring in. So I'll give an example actually where I used it recently. So we had like a test class, and we defined in traits the ability to kind of resolve dates, so like the date formats that we expected things to be in our assertions, and also if we wanted to load files for any kind of assertions. So maybe you wanted to check the output of some JSON against like a pre-baked file that you had. Well, in that instance, I could ask I could define my test class, and I could say, well, I want to bring in this test resources trait and this test formatters trait, and so I've now composed this functionality together. So do you see, it gives you that ability, rather than stick everything that you want for tests in one big fat abstract class, I can actually define it out and bring it in as I need it. So it's quite a neat feature. Go on. Yes. It doesn't. Yeah. That's yeah. Yeah, you do. That's right. Cool. Go ahead.
Can I ask what are the advantages that Scala brought to CVLA in terms of delivering value for money over Java, and what is the turnaround from migrating Java code to Scala in terms of time and money?
Okay, yeah, it's a really good question. I mean, these things can be really subjective and difficult to quantify, right? And I can't say that DVLA necessarily measured for that. But what I can say is that you can probably see for yourself that Scala does reduce a whole lot of boilerplate code. So if you just look at, like the collections example I'll point you back to again, if you're dealing with collections in that functional manner, it does in theory mean that your programming time is shortened. So I mean that would be the perceived main benefit. And the fact that you can be more expressive with your types means that in theory you're going to have end up with a closer mapping to the real domain model that you're dealing with. But of course those things are only tools to aid you to get there. You can't necessarily, the Scala does bring that, but it opens up the possibility for it. So, but they have had a little bit of a problem in getting Scala developers. So a lot of what's happened is that oftentimes it's Java developers who are cross-training into Scala. That's a very often scenario. Because Scala is still fairly young. Obviously, very young in comparison to Java. I think my time is definitely up. I've had more words, so thanks a lot for listening.